Assalamualaikum and hello everyone. We are group 3 and this is our group project for the course SECR2043 Operating System. The title of our project is Process Scheduling Algorithm, Round Robin and Multilevel Queue. This group consists of 4 members, which is ZUKHAIRI bin Muhammad Noor, DEVI YANA binti Muhammad YUSOF, Siti Munirah binti Ahmad, and myself, Siti HIDAYAH binti SAIMIN. Let's begin by understanding the key concept of an operating system or OS. What is OS? OS is a software that manages the overall operation of a computer or laptop. It controls system resources like CPU, memory, and storage. More importantly, it acts as the link between hardware and the user. Without an OS, we wouldn't be able to open application, move files, or even start the computer. In reality, multiple processes are always running, not just the app we open, but also system tasks like Wi-Fi connection, antivirus scans, notification, and background service. However, the CPU can only handle one process at a time. This is where multitasking comes in. The OS constantly switches between active processes so quickly that it feels like everything is happening at the same time. The component that handles this task is called the scheduler. Its job is to decide which process runs next on the CPU. To make this decision, the OS uses scheduling algorithm, which help ensure fairness, responsiveness, and efficiency. Without proper scheduling, the system could freeze, slow down, or crash. In this project, we will focus on 2 key scheduling algorithms. First, round robin, and second, multi-level queue. Both of these are used in real-world operating systems such as Linux, Windows, and Android, depending on the type and priority of the process. Now that we have covered the basic concept of the operating system and why process scheduling is important, let's move on to the next part, where we will take a closer look at how the round robin and multi-level queue algorithm work. To explain this further, I will pass the presentation to Yana.
What is round robin? Let's begin with round robin scheduling. This algorithm assigns each process a fixed unit of time called a time quantum. When a process time quantum is expressed, the CPU passes the next process in the queue. If the process is not finished, it goes to the end of the queue and wait for its next turn. This continues in circle fashion. That's why it's called round robin. This method is fair, ensuring that no process is stalled. Round robin in real-world application. Round robin is used in real-time and time-sharing systems, such as Linux, which has built a scheduler called SERI. For example, if you're running multiple terminal sessions of application in Linux, the round-robin schedule ensures each one gets CPU time equally and smoothly. It's best used when we want fitness among processes of equal priority. What is multi-level queue? Now, let's look at multi-level queue scheduling. In the approach process, a group in the different queue based on their characteristics of priority. For example, interactive process go to high priority queue, while background or batch process go to lower priority queue. Each queue can use the different scheduling method internally, such a round robin in one and first come, first serve in others. The schedule chooses which queue to serve based on predefined rules or priority level. Multi-level queue in real-world application. Multi-level queue scheduling is used in many modern operating systems. For instance, Windows OS assigns processes to different priority classes, such as foreground and background tasks. Similarly, in mobile operation system, background apps may be assigned to low priority queue to save battery and CPU usage. This allows critical tasks like use input in other playback to remain smooth and responsive.
Assalamualaikum, my name is Ahmad ZUKHAIRI. I want to present my project group round robin simulation. Now that we have seen how to Robin and Multilevel Queue walk into the real operation, let's take a look how to have simulate both algorithm in our project. In the round robin simulation, we create multiple process which different arrival time and birth time. We also apply a fixed time quantum to ensure every process get an equal CPU time slot. The CPU switch between process in a circular manner. This behavior is known as preemptive scheduling, where the running process can be interrupted and the CPU is reassigned to the next process in line. Multi-level queue simulation. In the multi-level queue simulation, we group process into different queue based in their type of priority. For example, interactive tasks were placed in the high priority queue that use round robin, while background or batch process we assign to a lower priority queue using first come, first serve. This CPU always give preference to high priority queue only when a highest priority queue is empty will to move on the serve to next queue. This simulate discrete queue separation and priority enforcement. Round robin Gantt chart. To better visualize the scheduling order, we generated a Gantt chart for each algorithm. In this chart for a round robin, you can see the CPU switch frequency between process at the fixed interval. This demonstrates how round robin ensure fairness and preemptive switching. Multi-level queue Gantt chart. Now, in the Gantt chart for multi-level queue, the separation between different queue become clear. High priority tasks are handled first, while lower priority tasks are delayed until the top queue is idle. This also show a combination of both preemptive and non-preemptive scheduling. For example, round robin may be used in the high priority queue, while first come first serve may be non-preemptive in the low priority queue.
Assalamualaikum and hi everyone, I'm Munirah. I will be wrapping up this presentation by summarizing what we have learned about round robin and multi-level queue scheduling or algorithm in operating system. I will also walk you through how we implemented this project and finally share our key takeaway from the whole experience we get from this project. Okay, throughout the previous presenter, we have explored two scheduling algorithms. The first one is round robin, which is fairly distribute CPU time across processes using a fixed time quantum. And second one is multi-level queue, which separates processes into multiple queue based on priority and types. Each algorithm serves a different purpose. Round robin is more balanced for a similar task, and for multi-level queue, offer more control in managing different type of processes. About the project implementation, firstly I will explain about the tools that we use. For this project, we focus on visual learning and explanation. Most of the slides we design using a Canva based on lecture note and our own research. We record our terminal output using a simple screen recorder in Linux Mint operating system and capture others' visual and explanation video. To simulate how round robin and multi-level queue algorithm work, we use a simulator builder from Canva to help us design a visual simulation. The logic and flow were guided by our understanding of concepts like a preemptive scheduling and queue priorities. We put a prompt in that Canva, in that simulator tool, based on our understanding and what we have learned about the round robin and also multi-level queue, and asking the tools to demonstrate or simulate how the round robin and also multi-level queue working in operating system. Finally, we edit and compile everything like slide, screen recording and team member explanation using a CapCut to create a smooth final video presentation before we upload to the YouTube. For a team collaboration, we make sure to follow the project guideline that given by our lecturer. So this project was truly a team effort. Each of us contribute our own time, knowledge and ideas, from researching and designing the content to preparing the visual and recording the videos. We discuss, review and support each other throughout the process to making sure every part was aligned and clearly explained. Now, I will share our key takeaway from this project. First, we have deepened our understanding of key operating system concepts like CPU scheduling, time quantum, and process queue, especially in round-robin and multi-level queue. Second, we explore how round-robin and multi-level queue algorithms are applied in real systems like Linux, Windows, and mobile operating system. Thirdly, and the last one, most importantly, we have learned how to plan and execute a complete video project, from content creation to simulation and presentation. This project helps us not only revise our syllabus, but also make us understand how operating system concept apply in the real-world application. Before we end this presentation, I would like to say a big thank you to Dr. Ismail, our operating system course lecturer, for his support and guidance throughout this semester. Thank you for watching, and Assalamualaikum.